If you are into deep hollowing, then there's no need to explain how hollowing systems work. You've definitely heard of captive systems like Lyle Jamison or One Way, and you certainly know about articulated arm rigs. The legendary Monster and Cobra systems have become history, with modern options like Elbow, Trent Bosch, and British-made Hope taking their place. To be honest, we spent a long time choosing a workhorse among these brands, but in the end, we decided to follow our own special path. And here is why. And today, we will take a detailed look at a completely different class of system, the linear hollowing rig, which is a deep hollowing system based on linear guide rails. We'll break down what it consists of, how it's designed from the inside out, and why conceptually it is on a whole different level. First and foremost, of course, is the base of the construction. It has to be rigid and lightweight at the same time. And here, extruded aluminum profile fits better than anything else. It is practically weightless, yet it possesses monumental strength. However, when selecting linear guide rails for it, you need to clearly understand from the get-go exactly what kind of assembly will sit on top and be responsible for the actual work of the cutter, because that is where all the magic happens. If you try to pit this design head-to-head against classic captive systems, some very significant nuances come to light. Despite their undisputed power and reliability, traditional systems involve a lot of heavy-duty steel. When you have a massive steel frame sliding through a steel backrest, friction is inevitable. Turners often have to resort to tricks like applying paste wax or graphite just to keep things moving. Even then, you're still fighting the physical weight and surface tension of the metal. In our linear rail setup, that resistance simply evaporates. Articulated arm systems are a slightly different story. They are fantastic, incredibly responsive rigs that are an absolute joy to use. They practically float in the air. However, this design faces its own unique challenges when it comes to extreme depths. A multi-jointed arm, by its very nature, functions as a complex lever system. The deeper you go into a vessel, the more leverage and stress are placed on those pivot points. To maintain absolute stability at a maximum overhang, the joints of the system would have to be colossally thick. With this linear rail setup, the physics of load distribution are fundamentally different. The trucks distribute the torque evenly along the entire length of the tracks, providing rock-solid rigidity no matter how far the cutter extends. But most importantly, it's about the physical toll on the turner. Deep hollowing is hard, physically demanding work, and if your back and joints are already starting to show their age, every hour spent fighting vibration turns into pure misery. The linear system completely solves this problem. Just listen and watch how the system moves. You won't hear any grinding. You aren't dragging tons of iron against its will. The entire movement happens literally at the touch of a single finger. And the satisfying sound, which distinctly reminds you of a sliding table saw carriage, transforms heavy labor into pure aesthetic pleasure. And that is exactly where the colossal advantage of the linear rig lies. It absorbs 100% of the dirty work and destructive vibration, saving your hands and lower back, leaving you with nothing but pure bliss and total control over the wall thickness. And since we are talking about rails, let's take a look at that very top assembly responsible for making it happen. The design operates on the principle of two perpendicular guide rails, which allow us to freely move the cutter in all directions: forward, backward, left, and right. Resting on the tool rest, the system creates a rock-solid support for the tool and allows you to align it perfectly flat with the lathe's center axis. This very assembly is what fixes that exact straight line along which the cutter will travel. The carriage on the vertical shaft not only locks the tool rigidly in place, but also allows you to adjust it to any desired height. On top of that, the system is completely universal. Thanks to a set of bushings, you can install cutters with any popular shank size, 1/2 inch, 5/8, 3/4, or 1 inch. And for the final touch, to make the tool travel absolutely effortless during stock removal, we added the ability to move the cutter along the axis of the shaft itself. In this combination, the mechanics deliver 100% freedom of movement across all planes and dimensions. My setup will feature a heavy-duty 1 1/8 inch bar from Lyle Jamieson, along with cutters for different types of tips. This is the exact kit I plan on working with. For the carbide and HSS cutters, Lyle's original holders will do the job perfectly. But for this specific tool here, I still need to make a shop-made holder. A few more words about the screen. The monitor that came with the camera is completely tiny, only 5 inches. Initially, I wanted to replace it right away with a large computer display and mount it higher up, right above the chuck. But in practice, it turned out that this solution isn't so ideal. First of all, constantly craning your head upward and not seeing what is happening on the lathe itself is quite an enjoyment. When you're turning, you absolutely need to keep an eye on the workpiece. Secondly, at high RPMs, with strong vibration, a heavy monitor on top risks simply crashing down. The small screen wins in this regard. It is damn convenient to place it down below, right next to the tool rest, where it is always in your field of view. But 5 inches is still a bit too small. For comfortable work, your eyes get tired quickly, and you have to constantly strain to see. All in all, we are still looking for the perfect solution, but we have already outlined the general contours of the correct workstation for ourselves. So, we've got our hollowing rig put together, and it's fully ready to roll. Join me in part 2 to see just how convenient it is to work with